Hello and welcome back. In this video, we'll look at Le Chatelier's principle, which describes how a system at equilibrium responds to an external disturbance. Le Chatelier's principle says that when a chemical system at equilibrium is disturbed, the system shifts in a direction that minimizes the disturbance. In other words, chemical systems at equilibrium respond to changes in ways that minimize the change. For example, consider the decomposition reaction of N2O4 to form NO2 at equilibrium. What happens if you add more NO2 to the equilibrium reaction mixture? The reaction shifts to the left, consuming some of the added NO2, forming additional N2O4, and thereby minimizing the disturbance. What happens if you add more N2O4 to the equilibrium reaction mixture? Well, the system will then shift right, consuming some of the added N2O4, forming additional NO2, and minimizing the disturbance. Now let's look at the effect of a volume change. Consider the reaction between nitrogen and hydrogen to form ammonia. Imagine the reaction at equilibrium in a cylinder equipped with a movable piston. What happens if you move the piston down, lowering the volume and therefore increasing the pressure in the cylinder? Well, according to Le Chatelier's principle, the system will respond to minimize the disturbance. In this case, the system should try to bring the pressure back down. How can this system do that? Well, look carefully at the balanced chemical equation. The reactant side has 4 moles of gas particles, and the product side has only 2 moles of gas particles. If this reaction shifts right, the total number of gas particles decreases, so the pressure will decrease as well. Therefore, the reaction shifts to the right to decrease the pressure and minimize the disturbance. What happens if you move the piston up, increasing the volume and thereby decreasing the pressure in the cylinder? The system responds in a way to increase the pressure, so it shifts left, toward the side with more moles of gaseous particles. Finally, let's look at the effect of a temperature change. The reaction between nitrogen and hydrogen to form ammonia is exothermic. You can think of heat as a product in an exothermic reaction. What happens if you raise the temperature of this reaction mixture? You can think of this as adding heat. Since heat is a product in this reaction, the reaction responds by shifting to the left. When the reaction shifts left, it absorbs some of the added heat and brings the temperature back down, establishing a new equilibrium. What happens if you lower the temperature of a reaction mixture? You can think of this as removing heat. Since heat is a product, the reaction shifts right to produce more heat. Endothermic reactions behave in the opposite way. You can think of heat as a reactant in an endothermic reaction. For example, the decomposition of N2O4 into NO2 is endothermic. When you increase the temperature of an endothermic reaction, that is, when you add heat, the reaction shifts right. When you decrease the temperature of an endothermic reaction, that is, when you remove heat, it shifts left. Consider the exothermic reaction A gas goes to 2B gas at equilibrium. Which set of changes would cause the greatest shift to the right towards the products? A, lowering the temperature and lowering the pressure. B, raising the temperature and raising the pressure. C, raising the temperature and lowering the pressure. Or D, lowering the temperature and raising the pressure. The correct answer is A, lowering the temperature and lowering the pressure. Lowering the temperature is like removing heat. Since heat is a product in an exothermic reaction, this causes a shift to the right. Lowering the pressure by increasing the volume causes the system to shift toward the side of the reaction with more moles of gaseous particles, so the reaction shifts right.